Greetings, class. This is the first segment where we tackle t-tests for two samples. Up to this point, you've dealt with confidence intervals that had to do with the t-distribution. You've dealt with t-tests for one sample. And now you're going to work with, this week, a procedure known as t-tests for two samples. Now, the good news is, if you have a good handle on how to use the t-probability distribution and have felt pretty confident in the calculation of confidence intervals as well as the conducting of t-tests for one sample, you should have no problem with t-tests for two samples. And in fact, I would go so far as to say that if you have a good understanding of how to use the t-probability distribution and also have a good understanding of the concepts of what probability distributions are, you shouldn't have really any major problems going forward with the additional tests that we're going to do. However, this week, as I just mentioned, is all about t-tests for two samples. Now, there are a couple of different kinds of t-tests for two samples. One is known as a t-test for independent samples, and as that name implies, that means you're comparing two samples and they are independent of one another. They're not linked at all, they are completely independent. So t-tests for two independent samples is one type of t-test for two samples. The other type of t-test for two samples, which we will probably just touch on, I want you to be aware of what that I want you to be aware of what that test entails, and I want you to know a few important things about it. But we probably won't actually conduct a t-test, this type of a t-test. The second type of t-test for two samples that I'm referring to is known as a t-test for two paired samples. The word paired suggests that the two samples are linked somehow, related somehow. So for example, if you wanted to compare two groups of people and those two groups were mothers and daughters, you could do that comparison using a t-test for paired samples, because mothers and daughters are naturally related, literally related, either genetically, legally, whatever, it doesn't matter. The point is, they're two separate groups, mothers, daughters, but they are inherently linked. So we'll probably touch on that a little bit more later on. But first I want to begin discussing t-tests for two samples, specifically t-tests for two independent samples. And I have here a handout. I will make this available on Blackboard. T-tests for two independent samples. Here's what you're doing with a t-test for two independent samples. You are analyzing the difference between two means. Now, you've already been analyzing the difference between two means, but you've been analyzing the difference between one sample mean and an assumed parameter mean. And you've been doing that via t-tests for one sample, comparing one sample to a population, or more specifically, comparing one sample mean to a population mean. In this case, you're still going to be analyzing the difference between two means, but you're going to be analyzing two sample means. Not one sample mean in a population, but two sample means. So, there are a couple of very important differences between t-tests for one sample versus t-tests for two. First, a t-test for two samples has to take two samples into account. The degrees of freedom have to be different, and we'll talk about how the degrees of freedom differ. It's not overly complicated, but it is an important difference that you'll need to keep in mind in order to choose the right t-value from the probability distribution and also to do the correct calculations. So degrees of freedom have to take two samples into account. Now let's talk about what that means, taking two samples into account. The reason you have to use the t probability distribution when doing t-tests for one sample, and I did purposely say one sample, the reason you have to use the t probability distribution when conducting t-tests for one sample is that the t distribution takes sampling error into account. Now, when you are conducting a t-test for one sample, you are only working with one sample. This is very important. You're only working with one sample, and as such, you only have to take, there's only one opportunity for error to enter into the mix. One sampling procedure would result in one opportunity for error to enter into our analyses. With t-tests for two samples, there are two opportunities for error to get into the mix. And so we have to take that into consideration. Which leads me to my second point. This is the same handout I was using before. We have to calculate a combined measure of standard error. So those are the most important differences that you need to keep in mind when conducting a t-test for one sample versus a t-test for two samples. These are the two things that really separate those two procedures drastically. And that is that the degrees of freedom must take two samples into account, and we have to calculate a combined measure for standard error. Before, you were just calculating the standard error for one sample, and it was pretty simple, was it not? Do you remember? Would you be able to write the formula by heart? Allow me. This is the formula you worked with before, right? That is the formula for the standard error for one sample. In a t-test for two samples, you need to take the error for two samples into account. So, I have a handful of things that I want to mention about the procedure, but in the interest of keeping these segments manageable, I'm going to cut this off now and start another segment in a little bit.